Bristol Community College, Mathematics with Dan Avedikian, Math 132, Calculus with Applications, Section 15.4, Problem 12. This is Section 15.4, Problem 12. We have the definite integral of 4 over the square root of x dx from 9 to 4. So to do this problem, I have two issues with it. One is that I have a square root with square root notation and that I have a variable in the denominator. So let me just rewrite it right next to it. Definite integral from 9 to 4 of 4 over x to the 1/2 power dx. That helps, but I still have a problem. My variable's in the denominator. Let me write it as the definite integral from 9 to 4 of 4x to the negative 1/2 dx. Now I have a form without my square root notation, my variables in the numerator. Now I can go ahead and actually start the 4-step process of solving my definite integral. Now I can take the integral. So the 4 in front will stay in front, and I take the exponent of negative 1/2, and I'm going to add 1 to it, and then x to the previous exponent of negative 1/2 plus 1. And again, there is plus a constant or plus c, but that's going to cancel for sure by the last step, so I won't even really bother to write it. So to do the fractions here, let me change that plus 1 to a plus 2 over 2. 2 over 2 is still 1, but now I have it in a form where I have a common denominator. And let me do the same thing with the exponent. Negative 1/2 plus 1 will change into negative 1/2 plus 2 over 2. Still a 1, but now I can combine my fractions. So I'll have 4 over negative 1/2 plus 2 over 2. Well, it's going to be positive 1/2. X to the same thing here. My common denominator is 2. My numerator is negative 1, positive 2. It becomes positive 1/2. And now the fraction over in the denominator, let me simplify that. When you have a fraction in the denominator, if you remember, what you have to do is invert it or flip it. It becomes 2 over 1 or just 2 times the top. So I have 2 times 4. I'm going to have 8x to the 1/2, which now that I'm going to actually start putting in my limits of integration, the 9 and the 4, let me write that instead of x to the 1/2. Let me write 8 square root of x. It's really 8 times square root of x. And now I'll put the long vertical line to the right of it. 9 is my upper limit of integration, and 4 is the lower limit. So that's the end of step 1. Step 2 is plug in the upper limit to my answer, plug in a 9. So 8 times square root of x would become 8 times square root of 9, which is really 8 times 3, which is 24. So the answer for step 2, when I put in the upper limit of integration for my variable, I get a result of 24. Step 3, put in the lower limit of integration. So 8 times square root of x becomes 8 times square root of 4. Square root of 4 is 2, so 8 times square root of 4 becomes 8 times 2, which is 16. And now the final step, step 4, I'm going to subtract the result from step 2, which is 24, minus the result from step 3, which is 16. 24 minus 16 is 8.